standing or moving? Obviously I'm standing. But Einstein, he asked himself the same question and exclaimed, I'm moving. And he gave us his profound discovery called theory of relativity. This table, this chair, you, the glass, the pen, everything is static. Let's think a little beyond. Since Earth rotates, everything on it on the move. Let's understand this with two aspects, speed and time. Speed. Let's imagine you're standing beside a railway track and train passes through with a speed of 80 kilometers per hour. And you are seeing a person inside a train. Inside a train he is static, but the train moves at 80 kilometers per hour and he also moves at 80 kilometers per hour. Now a second train comes on the next track with 60 kilometers per hour speed. So the person in the first train doesn't see that it moves at 60 kilometers per hour. He sees it moves much slower. This is because the first train's speed is relative to the second train. What happens if both the trains travel at the same speed? For example, 80 kilometers per hour. The person on each train will be consistently seeing each other. They would feel the train is not at all moving. So this is the basic concept of relativity theory. Let's see the time aspects. I am throwing this ball up and catching it back. So how long it would have taken? Theoretically we can say just 2 seconds. I am doing the same on a moving train. One thing is for sure, they will scold me because I am laying inside a train. Let me ignore them. So I am throwing at the same pace. So be it inside a train or outside a train, it goes up and comes back. So both should take exactly 2 seconds. But the train is on the move. So when the ball goes up, it goes like this. And when it comes down like this. So obviously if you see the distance, here it is more, even though we feel it's vertically going up and coming back. So both should be 2 seconds. Here, a marvelous truth unfolds. The time slows down itself. It reduces itself to cover the distance. So it may be 1 second, 998 milliseconds approximately. What will happen if the train moves faster? The time further slows down. This phenomenon is called time dilation. That theory, we call it as Einstein theory of, special theory of relativity. Let's replace the train with light. Light travels at 4.8 lakh kilometers per hour. Since the speed of light is always constant, when we apply the theory of relativity, we get amazing truths. Remember, when speed increases, time slows down. So if you could travel close to the speed of light, time reduces. When you could travel at the same speed of light, time stops. And here comes the wonder. If you could travel faster than light, then time reverses. This concept gave an idea for many movies on time travel and time machine. In fact, unfortunately so far, no machine has been invented which could travel at least 10% of the speed of light. Einstein also gave us another theory that is called general theory of relativity. According to this theory, the objects experience gravitational attraction to each other. If I leave an object here, it reaches the ground because of gravity. Moon rotates around Earth because of gravity. Planets rotates around sun because of gravity. So according to this theory, where the gravitation is more, time speeds up. So the special theory says when speed increases, time slows down. General theory says where gravitation is more, time speeds up. You might be having a question. What is the use of this? Where we are applying this theory? And how is it useful to you and me? One technology that uses this theory and has become part and parcel of our life is GPS system. Let me give you a brief idea about GPS system. There are 24 GPS satellites circling around Earth. There are 6 orbits, and each orbit 4 satellites are revolving. That ensures at any location, at any point of time, you can see 4 satellites visible. In fact, 3 satellites are enough to calculate the location. The 4th one is used to fine-tune it with altitude information. And here comes the relativity theory. Time slows down on moving object. So, the atomic clock in the satellite slows down by 7 microseconds per day. And as per general theory, the gravitation also impacts, and it makes the clock to run faster by 45 microseconds. So the clock is set to 38 microseconds to run ahead of the clock compared to Earth. That perfectly syncs the clocks between satellite and Earth. And how important it is. 1 second difference between the clocks between satellite and Earth will show you approximately 10 kilometer difference. So next time when you use map to reach Barbecue Nation, think of Einstein, think of relativity theory. So I have presented you a basics of relativity theory. But it would be pretty interesting if you deep dive in it. You would wonder, you would amaze, awestruck the technology that's embedded in our Mother Nature. Let's go and explore. Over to you.